decision rule, what I gave you on the whiteboard, under humidity, normal gives yes. Normal gives yes. Now first calculate the number of instances of normal. That is your denominator. So how many times the normal is occurring in humidity column?
7.
Yeah, wonderful. 7 is the denominator. Now, normal is yes. How many times the normal is yes and how many times the normal is no?
6 times yes, ma'am.
6 times? Yes. Wonderful. Good answer. How many times no then? Obviously. Out of 7 instances, it has
1.
to be. Okay. Now, what is the error? What is the error value? Whether it is
1 by 7.
Wonderful. Anila, you are answering me? Or
Anusha, ma'am.
Anusha. Thank you. Wonderful. Good answer. So 1 by 7 is the answer. Write it down. Now the next one we will quickly do it. Windy. Windy, windy. There are only 2 instances. True or false? True or false? So no confusion at all. True or false? Yes or no. That's it. Correct. So now windy is the attribute and we are deriving the decision rule as what? What is windy value? 2 possible values. True and false. Right?
True and false.
Okay, take down the first rule. We try to do it for false. False gives yes. Now, how many times the false is occurring under windy column? How many times the false is occurring under windy column? Count it and tell me.
8.
Wonderful. So your denominator is 8. Write down. Under the error column, you write it as 8. Now, let us take the count. How many instances of false giving play as yes and how many instances of false giving play as no? Give me the count.
6 yes, ma'am.
6 yes and 2 no. Right?
Yes, ma'am.
Right? Now, what is the error? 6 by 8 or 2 by 8? 2 by 8 is the answer.
2 by 8.
Wonderful. Write down. The other people also, please understand, these are all very easy. You need not by-heart this. You need not. Once you understand the concept and the logic back of this, a sample data set in exam, you can take it and write it unless the paper setter gives the tip as or hint as that you need to use this data set. If they give the data set, wonderful. You can apply the concept and the knowledge what you are gaining today to construct the decision tree. And how do we determine the root nodes? Wonderfully, in fraction of seconds to minutes, you can answer the question. You need not require more than 5 to 6 minutes to answer this. Are you getting? Right? Now, so false gives yes, we have done. Correct? False gives yes, we have done. The total errors are 2 by 8. Now, the same thing you do it for the other value of the windy. True. True is the other value or other instance. Okay, but how many times the true is coming? Because I need to compute the denominator for my error. So how many times the true is coming? True 1, 2, 3,
6.
4, 5, 6. Wonderful. 6 is the denominator. Now let us count how many true with the yes value of play, how many no with the true value, no value for the true. True with yes.
Yes, 3.
No.
Yes, 3, ma'am.
Yes 3 and no 3. So again,
Yes.
it's an ambiguity because both the values are same. So don't get the confusion. That's why I went back to the previous example to explain you how this error counts are calculated or how we are trying to generate this number of errors, right? So 3 by 6 is the answer. Now have one more column as the total error. Have one more column as the total error. Have one more column as the total error. Now, are you having the same table in your notebook? Total error, how will we generate? Yesterday only I taught you. How will we generate the total error? Because for Outlook yesterday we have seen All the denominators you need to count. That is for Outlook, 5 sunny instances, overcast 4 instances, rainy 5 instances. So the first attribute Outlook, the denominator is 5 plus 4 plus 5, it is 14, correct? Now all the numerators you add it, 2 plus 0 plus 0, 4. 4 divided by 14, we have got it as the total error. Any doubt in this? Any
No,
doubt in
ma'am.
this? No. But how do we justify this as an answer? Okay, as a concept. How do we say that? Why it is 4 by 14? Yesterday I explained you even this. By adding up all the error values of the Outlook, there are 4 errors out of 14. That is 4 by 14. In other words, what we can say? Outlook gives 10 correct answers because 14 minus 4 is 10. Outlook gives 10 correct answers, means 10 correct decisions. Sorry, it's not answer. 10 correct decisions out of 14. Out of 14. And 4 are incorrect decisions. 4 are incorrect decisions. So the same way for other parameters also we have computed the total errors for the temperature attribute is 5 by 14 because the denominators are 4 plus 6 plus 4. That is the instances of hot, mild, cool got added together. So 4 plus 6 plus 4 is 14. The denominator is same as Outlook because the instances are same. Obviously the denominator has to be same for the data set because that is number of rows. How many number of times it is occurring, that is immaterial, but the number of rows are 14 in my data set, so denominator is common for all the total error values, not to the error values, total error I'm talking about. And the number of errors what we got it with respect to each and every instance derived with the decision rule, the 2 plus 2 plus 1 is 5. So 5 by 14 is the temperature total error. 5 by 15 is the temperature total error. So what do you mean by that? There are 9 decisions are correct decisions. 9 decisions are correct decisions, or 9 decision rules are correct decision rules, and 5 are incorrect ones with respect to temperature attribute. With respect to temperature attribute. With respect to temperature attribute. Now, the third parameter is humidity humidity attribute. And again, there is a tie between the humidity and the Outlook. You can make an observation. Obviously, denominator has to be same and it is same as 14 for everything. But when we see from the two attributes, Outlook and humidity, the errors, what we got it as 4, right? So both Outlook and humidity attributes are having a tie between each other. So both have 4 errors out of 14 instances. So the tie can be broken using another criteria or a condition for the purity of the resulting subtree, right? So please underline this. There is an ambiguity between Outlook and humidity two attributes because there are 4 errors in both the attributes. There are 4 errors in both the attributes. So since there is a tie, the tie can be broken using another condition to get the purity of the resulting subtree. Resulting subtree. And one more thing we need to consider, some of the branches are completely error free. Some of the branches are completely error free. When we see the Outlook overcast, there are 2 yes and 2 no. So obviously when 2 yes and 2 no is there, so 0 error, correct? Are you getting? Sorry, Outlook yes, 4 instances all are yes only. There is no. So that's why we got the value for second row under Outlook. Overcast is equal to, overcast gives S as the rule. Then we got the error as 0. So no errors. Okay. So in some cases, the sum of the branches are completely free from the error. Then it is preferred to use the things from the perspective of the subtree with the error, without the error. So we need to give that concentration on drawing the tree for such kind of instances. And the outlook is a one error free branch. So outlook will have one error free branch, means it doesn't have any branch at all. Error free branch it is. But sunny will have an error, rainy will have an error. Okay, so the tie broken is in the favor of outlook, because outlook has got one rule which is an error free. Why I'm talking to you, because there is a condition we need to use it or apply it for the purity of the resulting subtrees, because there is a tie between outlook and humidity number of errors, which is nothing but 4 by 14, 4 by 14. For that I am explaining you this. Okay, so if all the errors were given in few of the subtrees as the branches, so some branches were completely error free or some branches were with error. Are you getting my point? So if the error free is there, say for example, when we see the table what we generated under outlook, overcast gives yes, got 0 errors. So outlook has one error free branch, one error free branch. That too for what value? For overcast value. For overcast value. So where there is no such kind of a subclass or the branch, we can derive it for humidity. We can derive it for humidity. Why? Because humidity doesn't have any error free. Humidity doesn't have any error free branch. So both the parameters, values of the humidity as high and normal rules has got an error. High got 3 by 7, normal got 1 by 7. Right? So what we do, so there is a tie, the tie can be broken up in favor of outlook, not for the humidity. So we are trying to make the favor of outlook. So the tie is broken in favor of outlook, and the decision tree will use the outlook as the first node. Please understand, from yesterday we are talking to you determining the root node of the decision tree. Now we are concluding what is our decision tree root node. Which attribute is the root node now? Please answer to me. What is the root node now? Outlook or temperature or
Outlook.
humidity? Outlook is the root node, right?
Root node.
So for splitting up of the variables, so first we need to ask the question. The question should be asked to what? Solve the game of the play or solve the play problem. So what is the value of the outlook? First question is, what is the value of the outlook? So any doubt up to this? We are in a position to determine what is the root node of our decision tree. Okay, what is the root node of the decision tree? Any doubt in this? Any doubt? I'm asking you. Now, after
No, ma'am.
understanding and determining the root node, see why I'm going little bit slow. This is wonderful concepts, techniques of data mining, which can be used, applied anywhere in your career, future career. Okay, so these are all used where data is there. You need all these techniques, any one of the technique or all these. Okay, so now we are concluding that we successfully learned and derived what is the root node of our decision tree for today, right? What is the root node of our decision tree? So root node is outlook. Root node is outlook. Right. Now, what is the value of the outlook is the question. So, what are the values of the outlook? Sunny, overcast, rainy. Okay. Now, the root is ready. Now, I need to find it out, the splitting up of the tree into branches. Correct? Splitting up of the tree into branches. Now, the next topic is splitting the tree. Splitting the tree. Okay, so root node is Outlook. Root node is Outlook. Don't worry about the left branch, right branch. I didn't still explain you that. We will do that quickly. Okay, but let us understand the one branch which is in the center of the slide. What is that branch? Overcast branch. It is having any branch? Further, it is having any data? No.
Yes.
Yes is there, but still, any table we are trying to derive it, because the overcast is
No, ma'am.
error free branch. Overcast is an error free branch. So from the root node, the decision tree will be split into three branches or three subtrees, because Outlook has got three values. One is sunny, another one is rainy, the third one is overcast. But the middle one I concentrated, because just now I explained why we have choiced Outlook as the root node, because there was a tie between the Outlook and the humidity, because they had the equal errors 4 by 14, 4 by 14. So then we applied a criteria for understanding the purity of resulting decision tree root node. Decision tree root node. No doubts up to this point? No doubts?
No, ma'am.
Others also please answer. This is not the class which is being taught or teaching for only few students. There are many students who are connected. You can unmute and say at least no doubts, ma'am, or we understood, ma'am. Please answer to me.
Understood, ma'am.
Wonderful. Okay, let us quickly do this and we will conclude for today's class. Okay, so we understood that there are three branches. That is Pakka. Three branches we need to have, but one branch we got no sub branches. Means now the subtree or the branches we are talking about. For overcast, we won't have any further branching because it is error free branch. Okay. Now the data for the root node is entirely divided into three segments, are three children's or the three nodes. So one for each value of the Outlook, and each value of the Outlook we understood that one is sunny, another one is overcast, the last one is rainy. Okay, are you getting? Now sunny, sunny. Why the whole values are depicted with respect to sunny now? How many instances were there for sunny? How many instances?
Temperature, humidity, windy.
Temperature, humidity, windy, play, that is obviously we need to derive. So my question was, how many times that sunny was there? Sorry, here. 1, 2, 3, 4, if I'm not wrong. How many times?
5.
5. 5. Okay. So what were the, 1 minute. Okay. For sunny, 2 by 5. The total errors were 4 by 14. Correct? 4 by 14, correct? Correct, no?
Yes, ma'am.
Okay. So when the play cannot be happened with respect to sunny, so those values are being picked up here in the table. So you need not worry too much on it, but understand that why the outlook, why the three branches sunny, rainy, and overcast. Okay, overcast, right? Are you getting my point? And he has derived the data for that. So the decision tree will look like this after the first level of splitting. So let me cross check if anything I have left out in the explanation. Give me a minute of time. So outlook divided into three categories, which we have understood, the three segments. So one each branch or the arrows coming out as the branches are giving each value of the outlook also we understood, and the sunny branch will inherit the data of the instances that had sunny as the value of the outlook, that has sunny as the outlook value. So how many times the sunny we had? 5 no.
Yes, ma'am.
So those 5 corresponding 4 variable values are being written in the table. You can just compare it and cross check with the data set. Okay. So similarly, further the same thing is given for the rainy. How many instances the rainy was there in our data set, and for that corresponding 4 other values of 4 columns has been copied as it is: temperature, humidity, windy, play. Correct? I'm asking you. Correct? You need to have the data set in front of your eyes. Otherwise, you will be seeing like why this yes, why this no, why this false, why this true. It is just the copy paste of the instances of sunny, instances of rainy. Correct? Because we had 5 sunny instances, 5 rainy instances. Are you remembering? Here, how many instances of sunny? Denominator under error column you see. 5 no?
Yes,
Correct?
ma'am.
How many instances of rainy was there? 5 no? Correct,
Yes,
right? Okay. But here this is error free. 0 by 4 is a error free. That's why it doesn't have any sub branches. But these two will have the sub branches because we need to apply the now splitting for this. Right. So 5 instances are copied as it is this. I'll go back and show you one at least. Rainy. In the data set, rainy. Okay. So, sorry, sunny. Hot, high, false, no. Let us go back quickly to the slide and check that one row. Then the other things you can compare it later. I'll be sending this presentation today to Teams, or else you can refer back to the textbook for the better understanding. See here, hot, high, false, no. Correct, no? Just a copy paste of 5 instances of sunny, 5 instances of rainy. So we will conclude at here. So tomorrow's class we will try to determine the next nodes of the tree. That is next to nodes of the tree, as similarly we have done. So there we will go a little bit fast because I already taught you for the first thing like the root node and the first level of the nodes what we derived. Now the determining the next level of nodes of the tree we are trying to do it. So it is a recursive process. So it's a recursive process or a recursive logic for the logic of the tree building. So which will be applied for each and every branch of the tree, for each and every branch of the tree. So now we need to derive the subtree or the node to be identified for the sunny, node to be identified for the rainy, node to be identified for the rainy. Are you getting? Are you getting? With respect
yes,
to what? The temperature, humidity, windy. Temperature, humidity, windy. So we need to use this temperature, humidity, windy for sunny. Temperature, humidity, windy for rainy. Are you getting my point now? A little bit deeper digging of the data is happening. Don't get the confusion. So we will do that tomorrow. Splitting up of the tree for the next level, we will do